Hi, this is Merlin today. I'm just gonna talk about Valorant today. Actually, this is not really related to our main topic. Our main topic is the how B3 works. Yeah, the main topic is how B3 works. But it's not related to the main. It's not related to the main topic. And actually, to introduce myself, my name is Merlin, and I'm now 22, and I'm a front-end engineer, web front-end engineer, and engineer. After I just developer. He's more front-end developer. And last year I worked at like one of the tech company in the Korea as a contract software engineer, contract front-end software engineer as in 9 months. So after working on the 9 months, I came back to my school, and I start studying again. And actually, in the 9 months, I really learned a lot of things. And before last day of the company, and I asked all the senior engineers or the grade engineers and that how to be a really good software engineer, and they say computer science is really important. So after the leaving this company, I studied like computer architecture and those kind of things. I tried to make some kind of like bootloader, because bootloader is software that directly communicate with the hardware. And when I came back to the our university, and I take course which is algorithm and data structure, and what else, and operating system, computer architecture. And my well, so my think about it. This is my thought about current my university, or I think it's also valid in other university. The software major and computer, like software, the computer science major is really dead. They trying to make tell students just memorize stuff rather than how to make the stuff. For example, it is really what Elon Musk and Mark Zuckerberg like cares about. It's really have to go deep and ask why. For example, let's say why we need Docker. So Docker is like what we know is the virtualization of operating system. But we don't have to care about some kind of the environment issue. But why virtualization of operating system? That's a environment issue, because operating system is actually also software, but it just the abstractions. So abstractions of computer architecture, which means that there's a x86, ARM, and MIFC, and there's a lot of computer architecture, and based on this, operating system is gonna be made. Example, x86, the Reno is gonna be made, ARM, there's the Mac OS is gonna be made, and MIPS is gonna be made. And so the operating system is heavily rely on the x86 architecture and ARM architecture and those kind of things, the computer architecture. But but the key thing is not really operating system thing. If you're trying to compile like the file, whatever software in x86 like Linux and Mac OS in the MIPS, you're able to learn that if you compile the file, the bin file in your Linux, and if you're trying to import it trying to use it into Mac OS, it's gonna be not working, because it's not really about operating system. It's actually the computer architecture itself. Computer architecture, because x86 and ARM, they both have different ISA, which is instructions architecture. They may have move. Example, x86 they use move or pop or push or those kind of things. But in the MIPS, I think they don't use like move, those kind of things. They have under their ISA. Based on the ISA, the that means that um their code might be same, but their compiled version is not the same. What do you mean compiled version? If you look at the assembly, there's no really if you look at how assembly looks like, there's like opcode or and like example move S1 to, it was like A1 to 3 and those kind of thing, and those kind of move opcode is actually declared as like the table of the bytecode. So which means that you don't have to think about those kind of like compile thing. Actually the bytecode of this assembly set is already being made, and that is really that's really rely on the architecture that you use, because example, because you have different ISA in, if you're trying to look at the x86 ARM, they both have different ISA, and they both different ISA. That means their compiled version, their assembly bytecode table is kind of different, and of course the compile is gonna be bytecode is gonna be not same. The operating system is the one who abstracted those kind of things, so it's also utilize those kind of system. And if you're trying to make a bin file, the bin file is not same, so we have to make a virtualization on the virtualization like abstraction layer to make it same. So which is why we use the Docker container. Actually, I really expected those kind of things, but they didn't do it. And also their exam was really terrible, that it doesn't really need some kind of deep understanding, deep thinking. It's like they put like pseudocode here, and they trying to give some kind of question that's really nonsense, but it's nonsense. It's not really practical, and that's not really being used in industry, but they just do it because for the grade. That's really nonsense. I think that's why computer science is really broken. So whatever. So sorry, I'm keep on complaining those kind of things. So the main topic is how B-tree works. So B-tree, what I say that B-tree is just it's just the like trying to solve the normal index algorithm, which is like binary search tree, those kind of thing. So B-tree, but the B-tree is, if you're trying to understand how B-tree it is and how to implement it, is really, you will find that it's kind of hard, and because we normally think about those kind of like empty space or the pointer as a left, and here's a right. This is left and this is right. So you can just declare as a code in the some kind of property left or right. But if you look at how the B-tree looks like, there's no kind of like explicit left or right. But how do we really manage those kind of things? You utilize sorting and based on the comparison of your query key, it get the index of it. Example, you say this is your root, so it's gonna be key is gonna be 17, and your children, so it's gonna be like node that has 10, so node 20. So this this code is represent those part. So, and let's say you wanna insert 18 is bigger than the current keys, right? It's not really smaller than key 17, so that means it overflows the current index. So your 17 index is 0, and the 18 is already out of your keys, so it's gonna be plus 1 of it here, so that's gonna be 1. And we found index that the query key 18 is gonna be go to the index 1 because it's already out of here, which means that you just pick the children that has one index, which is 20, and that means that we don't have to think about like left or right implicit variable. You just have to use those kind of like comparison value and get the appropriate index, and you can just find out that this part, the 1720, is you're going to 17 to 20. So that's really how it works. You don't have to really think about those kind of left or right, those kind of thing. And also, if you're also the CS that I'm trying to implement B3, a lot of like books, they're telling in the theory, if you look at the image, the theory is really kind of easy. Well, if you're trying to implement on your code, this isn't easy. There's a bunch of recursion if you're trying to make an insertion, and there's when your nodes can be the primary key and it has to prompt the parent, right? Your children has to be splitted, and if your children have the children, it also has split. So that's kind of really hard of the B3 because you have to think about the traverse thing. And also, the thing you have to understand is those kind of deletion thing. If you're trying to delete 6, it's really nice, but if you're trying to delete 12, you have to think about which one you have to borrow. Okay, example, you borrow 18. But what if you borrow 18 and 18 is the last key? So there's gonna be more issue. You borrow 18, so 18 can be here, but there's no children in this part. So you have to think about like those kind of like unbalanced tree in here in this part. So I think this is really kind of hard. So this is it. Have a nice day. See you next time. Bye bye.